All right, now that we have the two link arms assembled on the wheels and all the pegs in place, and we move the wheels, we notice we get a true movement and motion. What we need to do is get those wheels linked together. So that's going to require a couple of things. First of all, with that Revolute constraint that we have, we want to define a resting position. So 0 degrees would be a very simple resting position. So if I pick 0 degrees for one wheel and then go to the back wheel, also define 0 degrees, looks like that's okay. Let's go to from the left side to the right side, and we can slide that out of the way so we make sure we get the right constraint. Let's try 0 degrees again, and most of the time 0 degrees will offset those two so that one arm is forwards and one arm is backwards. Real trains are often 90 degrees offset, but 180 or 90, either one looks good. The train wants to do the freestyle stroke, not the butterfly. So one arm should be forwards, the other arm backwards. Okay, so after that, we have to make sure that make sure that the arms are linked together and the wheels are linked together, because now it would still be possible to have the 3.5-inch distance with one wheel being high and the other wheel being low, and the link arm kind of going diagonally instead of staying horizontal. So in order to do that, we're going to do a motion link. And the easiest way to do this is to do a motion link between the front wheel and the back wheel of each side and then tie the two together. So I'll go ahead and select those two, and we notice that the wheel is spinning forwards. If we reverse it, it doesn't work. So we can't just reverse it. If you have, and if it doesn't play, then perhaps you do need to reverse it, and that has to do with how you assembled those, and if if something was slightly flipped or not flipped, that affects how you do this part of the assembly. So first of all, we want to link those together and make sure one side is running. Okay, we say okay, and we see down here we have a motion link. So let's go to the other side of the train engine, and again make sure we get a motion link between the wheels. So that when we're selecting this, we're choosing the wheel revolution, which you also see that highlight in the browser. So I select the Revolute on the front wheel, the Revolute on the back wheel, and this time it's animating and it's spinning backwards. If I reverse it, it doesn't play. So if it doesn't play, don't reverse it. Then you would want to reverse it. And now we got one set of wheels spinning forwards, the other set of wheels spinning backwards. So that's going to cause a unique problem here that hopefully it's going to work this time. This is one of the more cumbersome things with Fusion, but this time let's go ahead and select the wheel Revolute. So we're adding a new one. And then again, zoom in, get good eyes, make sure you have the right Revolute. So what do I have going here? I've got one wheel spinning forwards, the other wheel spinning backwards. That's not going to traverse down the track very well. If I click reverse, oh, I've got both wheels now spinning forwards. So this time, even though it was animating before, reverse helped. Once in a while, when you initially do this, it won't rotate, and when you click reverse, it'll spin. If they both happen to be spinning backwards, that's okay. That's just going to affect the slider and the default values that are set up when we put the train on the track, whether they have to be positive or negative. But at this point, what's important is that both parts, both wheels are spinning forwards or backwards. Either one is okay. And That's the motion constraint. Next, we'll assemble the track and put the train on the track and get it driving.